With respect to the subject of errors in measurements, there were two types of errors, systematic and random. We noted that the systematic errors follow physical laws, and if the conditions producing them are observed, corrections can be computed to eliminate them. However, random errors exist in all observations, and some of the examples of random errors would be setting up the instrument in the wrong station, citing the wrong station, transcription errors in recording the observations, and so on. Mistakes should be removed when possible before the adjustments of traverses or even differential leveling occur. Experience has shown that random errors in surveying follow the mathematical laws of probability. For corrections of error, we have already seen in basic survey to use the balancing of interior angles for a traverse project. So if you take a look at this example and we had to balance all the interior angles, we have a lot of redundant lines that are interconnecting. So as an example, if we considered this horizontal survey network shown in this figure, if we use the compass rule to adjust the observations, we'd have a lot of different scenarios. So let me give you an example. If the compass rule was used to adjust the observation in the network, several solutions would be possible. To illustrate one variation, suppose that the traverse A, B, C, D, E, F, G back to A is adjusted first. Then holding the adjusted values of points G and E, traverse G, H, K, E is adjusted. And finally, holding the adjusted values on H and C, the traverse H, J, C is adjusted. This obviously would yield one solution, but there are many other possible approaches. In another variation, traverse A, B, C, D, E, F, G, A could be adjusted adjusted and then followed by G, H, J, C, and then H, K, E. This sequence would result in another solution, but with different adjusted values for points H, J, and K. There are a bunch of other variations. This just illustrates that the compass rule adjustment is properly referred to as an arbitrary method. On the other hand, the least squares method simultaneously adjusts all observations, and for a given set of weighted values, there's only one solution, that which yields the most probable value for the given set of observations. Now, explaining that tells us there are other ways to solve for a traverse adjustment or for a leveling circuit. By using the least squares adjustment, we'll have multiple equations. Therefore, we'll need to use matrices operations to solve for all of our unknowns to give us the most probable value. In the next videos, I'll go over examples of the computations for the least squares adjustment.